Welcome to your Introduction to Statistics, Unit 5, Lesson 3. Today we're going to make inverse normal calculations. So this means we're going to be finding z or x values that corresponds to a given area under the normal curve. So the left tail case is going to be the easiest case for us, whether you want to use the table or if you want to use your calculator. Left tail is going to be the most direct case for us. We're going to look up area A in the body of the table and use the corresponding z-value or use menu, statistics, distributions, inverse normal, and then put in the area. For the right tail case, we're going to have to utilize the fact that everything in the table is left tail, and the calculator is going to give you the cutoff for the left tail. So what you're going to have to do is, if you're interested in like the top 10%, you're going to have to do 1 minus 0.1 for 10% and get 0.9. So if you're interested in this cutoff score for the top 10%, it's the same thing as the cutoff score for the bottom 90%. So you're going to look up the number 1 minus a in the body of the table and use the corresponding z-value, or do menu, statistics, distribution, inverse normal, and do 1 minus a. For the center case, okay, you're going to look up the number 1 minus a over 2 because you've got a out of the middle. You have 1 minus a in both tails together. So each tail alone, you have 1 minus a over 2 area. So the left tail is going to be 1 minus a over 2 and use the corresponding positive and negative z-value. So use the z-value you get and then change the sign, and that'll give you the upper z-value. Or you can use menu, statistics, distributions, inverse normal, 1 minus a over 2. That'll give you the negative z-value. So use that and then the corresponding upper z-value. Okay, so use the nearest area value rather than interpolating, trying to be more specific than that. If you need to, when the area is exactly halfway between two area values, use the z-value exactly halfway between the z-values of the corresponding table areas. So one will be closer than the other, or it'll be exactly halfway in between. So figure out which case you've got. Okay, so we want to find the indicated z-score. We want the z-score that marks off the lowest 0.0051, the area that is 0.0051 to the left. So we find that in the body of the table. So you scan, scan, scan. Oh, here it is. And then look, you can see that the units and tenths digits are negative 2.5, and then it's in the 0.07 column. So the z-score is negative 2.57. Okay. All right, we want the z-score that marks off the top 1%, the top 0.01 area. So we do 1 minus 0.01 and we get 0.99. Because the table has 4 digits, you want to add zeros to that, so 0.9900. So you find 0.9900 in the body of the table, and you get z equals 2.33. You could also do inverse normal in your calculator and put in 0.99, and it's going to give you 2.33. Okay, the middle, 0.7814. So you do 1 minus 0.7814 divided by 2, and you find the corresponding z-score for that area, and that's going to give you negative 1.23. And so then your positive z-value, you just drop the negative. All right, we want the area between negative z and positive z to be 99%. So that gives us 1% or 0.01 in both tails. Divide that by 2 and you get 0.005. You find 0.0050 in the table, or the closest entry to that, and you get negative 2.58. So then you drop the negative and it gives you the positive 2.58. Okay, if the area in between is 95%, that gives you 5% in both tails. So 2.5% or 0.025 in the lower tail. And so you look that up and you get plus or minus 1.96. Okay, we're going to actually now go ahead and then convert from z-scores to x-scores to observations. So the verbal SAT has a mean score of 500 and a standard deviation of 100. Scores are normally distributed. A major university determines that it will accept only students whose verbal SAT scores are in the top 4%. What is the minimum score that a student must earn to be accepted? Okay, so the student needs to be in the top 4%, which means 96% of scores will be below the student score. And so you look up 0.9600 in your table, or you do inverse normal 0.9600, and you get a z-score of 1.75. And then, so we know the cutoff score is 1.75 standard deviations above the mean. So now we want to use the fact that the mean is 500 and the standard deviation is 100. And we'll use the fact that it's going to be z times sigma, so 1.75 times 100, so 175, plus the mean, so plus 500, 675. So the cutoff score for the top 4% is 675 for the verbal SAT. Okay, guys, go ahead and try the problems to try on your own. If you have any questions, come by and see me. Thank you for watching the video and taking good notes. I hope you have a great day, and I will see you in class.